everybody, we're going to be doing some science and we are going to be investigating how parachutes work. Now, for those of you that are not sure what parachute is, parachutes are what like skydivers do, and they help to people that are falling through the air, help them land softly. So we're going to create 3 parachutes. You might choose to do a slight variation of this. That's up to you. But we're going to cover some things that you need to consider if you are going to do it slightly differently. So, 3 parachutes, a large, a medium and a small. We're going to test them all, and there are some things that we need to keep the same. So we might need to keep the same weight and the same string length. We need to make sure, remember what they're called? They're called our control variables. So, things I want you to consider. So as you're conducting your investigation, just have a think about them. So this is our independent variable. This is the thing that we're going to change on purpose in order to conduct our investigation. So for me, I am going to do the surface area. So the surface area is how big the parachute is. Essentially, is how much surface there is. So I've done a 15 centimeters by 15 centimeters, a 30 centimeters by 30 centimeters, and a 60 centimeters by 60 centimeters parachute. Now a dependent variable, and that is what we are going to measure. That's what we're going to record, and that is, I've got mine down as my rate of descent. So that's how quickly it falls from the ceiling to the floor. And the way I'm going to do that is with a timer, a stopwatch. I'm going to stop it. I'm going to start it when I first drop it, and I will stop it when it hits the floor. Control variables. So these are things that I must keep controlled, or I must keep the same for each attempt in order for my results to be valid and fair. So one thing you might consider is the height, making sure your height is always consistent. Material, you might, what I did, I used a bin liner, so a black sack, and I used a black sack for every parachute. Now it is possible for you to have your material as your independent variable, but you would have to put your surface area in your controlled variable. So you would change the types of material, but you would keep the surface area the same. That's one alternative way of doing it. The string length and the weight of the objects that is going to be dropping. So consider all of those and just have a think about when you're conducting them. This is on my list of control variables. I must be really careful. So when you're conducting it, you're going to want to collect some of your results. Now I've got a simple table here, and I've got my parachute sizes here, my 3 different parachute sizes, and what I'm going to do is I'm going to drop the parachute, I'll start the timer, and then I'll stop the timer when it hits the floor. Nice and simple there. And what I'm going to do to make my results a bit more reliable, I'm going to repeat it 3 times. It says there for each height. It actually means for each parachute size. So that will mean I'll have a lot more results than if I just did it once. If I did it once, I would just have 3 results. But actually, now I'm doing it 3 times, I actually get 9 results. So sometimes we have what's called anomalies or anomalous results, which is when one result, something might have gone wrong and it doesn't actually fit our pattern. Actually, your biggest one, your biggest parachute, you might expect it to take the longest, but actually it fell right to the bottom because you forgot to open it up. That's fine. That still stay in our results, but we can just make a note of that in our conclusion that was one of our anomalous results. It didn't follow a pattern. So this is something that I would do. You might just have 2 columns going down, parachute size and attempt, but you might have the size on there multiple times. There are lots of different ways of conducting and recording this. So what I want you to do is I'm going to show you a video, and that is just how I've done it. I mean, you can do yours a lot more carefully and take a lot of time in doing it and have fun with it. You might do more than 3 types of parachute. You might do 4 different sizes. You might do 10 different sizes. But what I would say is, to keep it consistent, try and use square or rectangular shapes rather than in circles, unless you can consistently measure the circumference of your circle. So watch the video and we will talk you through what we are doing. So here we have everything that you're going to need. We have scissors, paper. The paper is just to hold the weight, so if you use something like paper clips, that's fine. I used a bin liner. Try and keep your material the same. I just knew that I had a bin liner and I could cut several different sizes out of the same bin liner. Also, I have a pencil just for drawing things, and I used a ruler, and I also used some shoelaces which you can't see. So here we have a picture of my different sizes, and so we can see the shoelaces, you can actually see them now, and this is sort of how I made the bucket. So you can see that I've hole punched these together and made almost like a little boat. I put the ball in. I ended up changing that yellow golf ball to one of the foam indoor golf balls, just because that was a little bit too heavy. So what I did, there we go, I ended up using that one just because it wasn't so heavy. So what I did was I took the shoelaces and I poked them through the hole because I didn't have any string, so I used some shoelaces, and then I poked them through. I'm going to do that on both sides, and then I'm just going to fold over the corners of the black bin liner to make them double strong, poke the shoelace through, tie a little knot, and I did that on all 4 corners. So you can see I'm laying it out, making sure I'm not making any mistakes. It's just slightly off camera. You should be able to see some of the other ones. So I'm just folding over the corner so it's sort of double as strong, because there's 2 layers for it to go through. And what I did is I just tried a loose knot on the other side because I knew that I'd need to reuse the shoelace on some of the other parachutes. Now if you've got lots of string, maybe you could keep the parachutes. I had to reuse the string, but that's absolutely fine. So here in this corner you can see that I folded it over. All I'm doing is I'm just being really careful and poking it through. Now you could use a pointy object to poke that through, but please be careful if you're going to do that. You were very sensible when we did sewing at the end, to just be careful. So now I'm making sure that I haven't crossed any of the wires. Again, folding that corner over to make sure it's double as strong. That's up to you. So going back to the sizes, I did a 60cm by 60cm piece of material. That's the one you can see here. So I used a ruler, 60cm by 60cm. I also halved that and did a 30cm by 30cm, and I did a 15 by 15. Well done if you notice that I halved the dimensions each time. I wanted to see if would halving the surface area of the parachute, would that affect the rate of descent? But look, this is how it works. I sort of turn it upside down, and when I let it go, actually I am going to spread it out. So here we go. Here's my first attempt. So this is the big one. You will notice that it does fly off the camera, but I'm just opening it out and watching it drop, and I'm also timing it. Here's my medium one. So this is the 30cm. I'm trying to hold it up to the same height. You'll notice that the position changed. That is just because I couldn't get a wide enough shot. But I'm trying to keep it the same, and I drop it, and you'll notice it flies off a little bit. That was, I think, about just under 3 seconds. The other one was just over 5, and this one is the really small one. And to be honest, this didn't fall as quickly as I thought it would be. It would. So there we go. There's my method. That's what I did. Now you can, I suggest you drop these multiple times. So I would suggest you drop each one 3 times, record the time, and we can get what's called an average, and we'll talk a little bit about that a bit later. So you've completed your investigation, well done. But let's just have a little discussion. What exactly was happening, because we are looking at forces and things like that. So what exactly was happening? So let's think about what air is. So air is all around us. We use it to breathe, and we can't see it, but we can feel its effects. Like we can breathe when it's windy. We can feel air against us when we're running really fast. We can feel air against us. Cars feel the air pushing against us, and what we call that air resistance. And that's when the air, because the air is made up of lots and lots and lots of different parts, really, really small particles. So there is something there, even if we can't actually see it. So we can just imagine there's all these little particles. We've got things like oxygen, carbon dioxide, and there's loads and loads and loads of more. And it's all around that, and that's all sort of getting in the way. So think about when you're running really fast, your hair's behind you. Now, as I said, that's called air resistance, when the air is resisting us. And it can also be called by a different name, and that is called drag. Now, drag is the resistance you feel when you are moving through air. So if you imagine, we've got a force pulling this down. Have a think about what that force is. Well done. That force is, of course, gravity. So gravity is pulling us down. And what's happening is this, where have we gone? This parachute has to go through all of that air. There's a resistance, and it almost has to push it out of the way. So it's trying to push all of this out of the way, and that's where we get our air resistance from. Now you can imagine if we had a piece of paper. That's a very odd shaped piece of paper, and actually that piece of paper is falling. We can imagine, you'll notice sometimes it sways as it goes down, and it falls quite slowly, because it has all of this space is pushing all of that air out of the way. Now think about if that piece of paper was actually up like that and it's still going down. This is easily able to push all of these out of the way. So air resistance is a force, and in this case it slows the parachute's descent. So we've got air resistance that is pushing up, and our gravity is pushing us down. So that's pretty much the gist of what's happening. And now we sort of know the mechanics, we can sort of think about, I can make an assumption about what your results have shown. If you think about it, we've got a really small parachute here, and actually you might have a really large parachute. Now if we have a think about it, which one is going to cause more resistance? It's going to be our large one, because it's got to push all of this air. It's got to move out of the way, but this has only got a small bit. So I can make an assumption from your results that I would imagine the parachute with the smaller surface area fell the quickest. And that's because there was less resistance on it, because it had a smaller surface area. There was less of that parachute being resisted by the air. And I hope that's clear. I will probably link another video, but that's pretty much the gist of what's happening. Now, what I want you to do is we're going to have a look at some conclusions. Now, there are 2 Chile, a 1 Chile, and a 3 Chile. Now, the 3 Chile's got 2 sections, and I will put them up as a PDF for you to fill in and complete. It would also be very nice if you could include a video of your investigation. I'd be really interested to see it. I know I've seen some videos from the previous one, or maybe a little write-up, but at the minimum I would like you to do your conclusion, because that's when our reflection on what's happened and our real learning is coming into play. So pick a conclusion, challenge, and have a go. So here's our first one here. This is our 1 Chile. All I want you to do is just fill in these blanks. I'm not going to read it because you can do that. We've got some keywords down the bottom. Have a look at use those keywords in those areas. and then we're going to fill in our evaluation. For our 2 chili, again, it's very similar. It's still a conclusion. As the what changed or decreased, what happened? So as the surface area decreased, what happened to it? How do you know this? Use some data from your table that you table of results that you recorded, and a little evaluation here. Think about your control variable. Now our final one here, I expect a lot more detail, and you're going to be using some of your brilliant scientific knowledge to explain what you did, explain your results, any patterns that you notice, because just like in maths, in science, we see patterns all of the time. A little evaluation about our control variable and things like that, and we've got a little extra bit. And now we've got a word here. We've got, can you explain any anomalous results? Can you remember what anomalous means? Now anomalous comes from the word anomaly, and that means something that doesn't fit the pattern. So sometimes we might get like a rogue result in there, one result that really doesn't fit, and some people like to ignore them and then redo it. But actually, most of the time, scientists collect all data. It doesn't matter if it fits what they want or not, they will collect it, and these anomaly results are normally identified, and normally something's gone wrong. So it might be nice for you to reflect on what you think went wrong. So if there was something, this one was an anomaly because I didn't open the parachute when I dropped it. So then we're talking about being fair tests, and remember that's keeping our controlled variables very controlled, and then think about how you can increase the validity of your results. So how do you make it more fair? How do you make it more reliable? Good luck, and I look forward to seeing what you can get up to.